Hi everyone, welcome to our YouTube channel, Civil Engineering Made Easy. We appreciate your concern. In case you're new here, consider subscribing. And to our regular subscribers, we are very much thankful for you, for your time that you have been interacting in this channel. In case you have a question on survey neck papers, especially on transit, board witch and curve wrenching, kindly post that question there on the comment section so that we can tackle it and then post it here for you. Knowledge is to be shared.
The question was set on 2022 July, neck, and it was on civil engineering and building technology. So the question was set on 2022 July. It was for building technology combined with civil engineering and architecture. So the question was number 5. I'm going to do the surveying question. So the question is here. It was for surveying students. So the question was set for civil engineers. So let me read the question. Two tangents intersecting at an angle of 150 degrees, 00 minutes, 00 seconds at a chainage of 1250 meters are to be joined by a simple circular curve of radius to 50 meters. Given the standard chord of 20 meters, compute the static data for the curve by deflection angle method on and through a chainage. So I've written a question, I've written it here, so I'm going to solve it on my book. So I've written it here. So it was set on 20 July. So let me put this one aside. So before we tackle this question, let's sketch a simple curve. Let me draw a sketch of a simple curve. This is a sketch of a simple curve. We have the origin, radius. We have been given the radius. The radius is 250 meters. And deflection angle. No, we have not been given deflection, but we have given angle of intersection. Intersection is 150 degrees. 00. So getting this one, just take 150, 180, 1 degrees minus 150 degrees, 00 minutes, 2 seconds, and you will get what? You will get this one to be 30 degrees, 00 minutes, 00 seconds. So the deflection angle is this one. Okay. Then we have been given the chainage of point of intersection. Chainage of point of intersection is 1250 meters. Okay. Then what else have we been given? So 20 meters standard chord of 20 meters. Now let's get the first chain. This one, T1. We normally call it T1 and T2. So this is the data again. This is the provided data. The provided data is here. So let's get T1. T1 is equal to chainage of point of intersection, which is this one, minus tangent length. So this is the first thing. The second thing, calculate. Second thing, arc length. Arc length is equal to arc length is equal to 0 degrees pi r over 180. So this is the formula of calculating arc length. Then after that, we calculate T2, which is the last chainage. The formula is T1 plus arc length. Yes, after that, then now let me calculate this. So tangent length. The formula of tangent length is r tan deflection over 2. Yes, I'm starting with this one because we have been given this one to be 1250. So let's find this one. Let's find this one. So r, which is 250 meters, tan theta over 2. This one over 2, 15 degrees, 00 minutes, 00 seconds. You go to what? Put it in your calculator. 250 degrees, 250 meters, or 250 tan, 15 degrees, 00 seconds, minutes, 0 seconds. You go to what? 66. So tan is equal to 66.9873. Okay. So this one. Now let's get T1. T1 change at point of the first chain and use T1. So T1 is equal to this one, 1250 minus this one, the given one, the one we have been provided with, 66973. Now 1250 minus 66.9873. You get what? You get 1183.0127. So this is the first unit. The second one, arc length. Arc length is, this one is 30 degrees, 0 minutes, 0 second, times pi times 250 over 180. Okay, let's put in a calculator. Degrees this one times shift pi times 250 divided by 180. Get what? 130.89. On that point 89.97. So that is the curve length there. So let's get T2. So T2, the last chainage, which is T2, is T1 plus arc length. So T1, we got this one, 1183.0127 plus plus arc length 130.8997. Add that one, please. Add that one. 0127 plus 130.8997. Yes, get what? 13 what? We get what? 13.9. So this is the last chainage. First chainage, last chainage. Now to that point, I think we're getting something. Then after that, now let's get what? Initial sub-chord, and final sub-chord. Yes, but before we get that, before we get that, we get that standard subcode we have been given to be 20. Before we reach that, to getting this one, let's get the number of subcode that we will have. So the cuff length, we have the cuff length, which is cuff length or arc length. Cuff length or arc length is 130.8997 meters. So we divide by 20 subchords to get a number of chords. So number of chords. So that divided by those one, 130.8997 divided by 20. Get what? 6.5. So it will be 6 subchords. So the number of subchords will be 6. Now let's calculate the total distance that this subchord will take. I normally do this. So this is the first chain, the last chain, T1. Let me demonstrate well for you. So we have T1, T2. So we want to calculate the first subcode and the last subcode, or the initial subcode and the final subcode. This part. We have 6 subcodes with length of 20. It will be 120. It will take a length of 120 from here up to here. It will take 120, and the length of all arc length is 130. So take 130.8997 minus this one. So we can find what? Let's minus do that. Please do that. Point. It's 997 minus 120. Get what? 10.8997. So this remaining distance is this remaining part, this initial subcode and final subcode. It will share this one, but now we want to separate. We don't divide by 2. Don't divide by 2 because we don't know the distance of here. So take this one. Before you take that, just put it here, then come. Say the first chain. The first chain was what? This one. So we make this one, we move this one aside, move this one above. So you take this, do this. 1170, 1180, 1190. So this one now it lies here, but when we move ahead, it will come here. So it will be 1190 minus this code now. Tell me. Just minus, so that we can get the first initial subcode. Let me put one in my calculator. 11.0000 minus what? Minus 11. It's a very point 0127. Yeah, it will be 6. The first initial, it will be 6.9873. So this one, the first is this one, but now the total of it, this one. So we get 6 plus unknown, which is final. Let's put F is equal to 10.8997. I've said it. We have found the first initial code to be this one, and we got this one after taking total half length minus the length of standard code, which is 120. We got this one. So we found that this distance plus this one, it is 10.8997 but now we have gotten the first or initial subcode to be this one. So let's get the final. So take this one plus this one, it will add this one. So let's get the unknown. We take this one to this side, be minus, and then f it will be, so move this one this side, it will be minus this one. So take this one minus 6. So this one is the first one, this one the first one. So let's get the last one. Take this one minus this one, it will be 73 minus, then you will get the final code subcode to be 8997 minus, it will be 3.9124. Now let's confirm. Let us confirm. Initial subcode plus final subcode plus total length of standard codes should give you what? 130.89, 130.8997. So plus we got the initial to be 6.6. Let's look here. 6.898, 6.9873 plus final 3.9124 plus this one 120 had 6.9873 plus 3.9124 plus 120. Automatically you will get this one. So that one confirms that you are correct. Meters. Now this one is initial subcodes, final subcode, subcode H, initial subcode, final subcode. Then now let's get deflection angles. The formula of deflection angles, the formula is 90L pi r. First deflection angle, we got what? This one. So we say 90L times 9873 over pi times r. R was 250. R was 250. Then put in your calculator 6.90 L 90 times 6.9873. Yes. Divided by pi, divided by shift pi. No. Let me put it all. 90 times 6.9873 close bracket and divided by open bracket shift pi. Yes, times the radius is 250 close bracket. You get what? Get this one degrees 0 0 degrees 48 minutes 2 seconds. Okay, so this one is first deflection, first deflection angle, and then we have standard deflection angle 90 times length is L is 20 because standard, then pi times 250 90L, then put in your calculator again, go open bracket 90 times 20, and then close bracket divided by open bracket pi times 250, close, then you get what, 2 degrees and 17 minutes and 31 seconds. Last one, final subchord 90L times, this one is how many times? This one is six times. You book it 6 times, but we are going to do that. So this one is 3.9124 over pi radius 250. Put in your calculator 90 times 3.9124 close bracket divided by open bracket pi times 250 close bracket, then 0 degrees, so 0 degrees 26 minutes 54 seconds. Now let's tabulate. Let us tabulate now. So the first one is point. We have point here, we have chain edge, we have chord length, we have deflection angles, then we have total deflection angles. We have point, chain edge, chord length, deflection angles, total deflection angle. Then you can do this. Don't mind my work, but yours should be beautiful as possible. So this mine, don't mind mine. Okay, this one. So now we start with point 1 to be T1. Then we have 6 subchords. So now we book 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 8. Then we have 2. Okay, now first chain edge. The first chain was let's come here. First chain was 11. So this is the first chain edge, 1183.0127. Is it so? Yeah, I think. And the last one was 13. The last one was T2 was 13.9124. 13.9124. Then one chord length ES dash. Then we have here chord length of here. We have here to be the first initial angle. This one initial subchord is this distance now. This first distance was 6.9873, and the last one is this one 3.9124. 1, 2, 3, 4, 5, 6. Yes. Now we had this one. We got what? 11.03.01. No, 0.127 plus 6.9873. We get 1190. Here we got 1190. We had 20. We booked 6 times because we were told that subchords were 6. You remember that? We got 6. We got 6 subchords. We got 6 subchords. After dividing with this one, we got 6 subchords. So now Now we book this one 6 times. 2, 1, 2, 3, 4, 5, 6. Then we had this one. This one will be what? 11, 10. No, 11, 10. 1190 plus 20. 1190 plus 20 will be what? 12. 10 again plus 20. Don't rub anything. 12, 30 plus 1190 plus 20 again. It will be 1250 plus 20 again. It will be 1270. 1290 tomorrow 1290 1290 1293 1310 1310 plus this one plus this one. Let's confirm if we can get this one, plus 3.91 24. You get what? 13 13 and 91, the same as this one, and I think you are getting that one. Then here is 0, and deflection is 0 0. This will go 0 0 again, 0 0 again, 0 0 again, because we don't have chord length. Then come here. Here now, we got the first or initial subchord, the first one to be this one here. So we book it here. We book here is 748, and then this one we have this one to be this one. So we book 6 times again. 17 degree, 2 degrees, 17 minutes, 31 seconds. Again we repeat it 6 times, and the last one is this one. Final, we book it here. Okay. So we repeat this one 6 times. Yes. Grace 17 minutes and 1 second. So now let's get this part. So this is a total deflection or cumulative frequency. We do cumulative frequency. Add this one, remain the same. 48 minutes to seconds. Add this one. Take 0 degrees. 48 minutes 2 seconds plus this one. 2 degrees 2 degrees 2 degrees 2 degrees 2 degrees 17 minutes 31 seconds. I go to what? I go to 3 degrees 5 minutes 33 seconds. Don't rub anything. That's hard. Degrees 2 degrees again 17 minutes 31 seconds. Got 5 degrees 23 what? Minutes 4 seconds. Hard again. Don't rub anything. Continue adding. 2 degrees 17 minutes 31 seconds. And we have 7 degrees 40 minutes 5 seconds. Then continue adding, and 2 degrees 17 minutes 1 seconds. And we got 9 degrees 58 minutes 6 seconds. Continue adding. We have 2 degrees 17 minutes 1 seconds. When we got 12 degrees 17 15 7. Then continue adding 2 degrees 17 minutes. We have what? At 1 second. You got 14. 14 is 1. That there is minutes. 8. What? Second. Then add the last one, this one. We go to what? 0 degrees, 26 minutes, 54 seconds. You get 15 degrees, 0 minutes to what? Second. Now, if you want to confirm that you are right, check this one. If this one half, it is half the deflection angle. We got the deflection angle was 30 degrees, so 0. So when we divide, we get 15 degrees, so 0 minutes. So this is the deflection angle, but the half of the deflection angle is this one. So if the last cumulative frequency is half of the deflection angle, you are correct. Now I think you have gotten the message. Thank you. Please like, subscribe and share.